Namaskar and hello aspirants. This is the second video of this series in which we were discussing motor design components MCQ. These questions have been already asked in various exams and we will discuss and we will take reference from other websites also for its discussion. Our first question is: lubricating oil is supplied to the crankpin bearing in a marine diesel engine by, and the options are internal crankshaft passage immersion in oil, spclearance lubrication, injection lubrication. The correct answer for this question should be internal crankshaft passage. The person who have already seen my previous video must be able to answer this question. Yes. Now let's see what is internal crankshaft passages. Yes, you can see in this image, this is a image of a crankshaft. In this you can see these all are the passages for the lubrication of the main bearing, bottom end bearing, and through these passages lubrication oil goes and it ejects from all these places and do the lubrication. Okay, now let's move to the next question. Gudgeonpin bearing are difficult to lubricate because of their oscillating motion and the options are their free floating design, their relatively small size, the reciprocating motion of the piston, their position in the lubrication system, and the correct answer should be their position in the lubrication system. The Gudgeonpin is also known as wrist pin and it is just below the piston. Okay, piston bearing or Gudgeonpin bearing all are same. Yes, you can see the same image will come. Yes, Gudgeon bearing. Yes, you can see in this image, it's a good image. You can see this is the piston and this is the piston crown. Just below it there is a piston pin and piston rod is connected with this and it is positioned inside this hole with the help of a snap ring or circlip. Snap ring is also known as circlip. It's inside circlip and a special plier is required to open to remove the circlip, which is known as circlip plier. That too is of two types: outside circlip plier and inside circlip plier. And it's due to this its position, lubrication is very difficult. A passage has to be built inside this piston rod through which lubricating oil passes and it goes to these places. Hence it is very difficult to lubricate this due to its position. Now let's move to the next question. The camshaft drive is designed to maintain proper camshaft speed relative to the crankshaft speed. In maintaining this relationship, the crankshaft drive causes the camshaft to rotate at 1/2 crankshaft speed in a 2-stroke cycle diesel engine, crankshaft speed in a 2-stroke diesel engine, 2 times crankshaft speed in a 2-stroke cycle diesel engine, 1/4 times crankshaft speed in a 4-stroke cycle diesel. Its answer should be crankshaft speed in a 2-stroke cycle diesel engine, because for every revolution in a 2-stroke diesel engine there is one revolution of the camshaft. 1/2 of the crankshaft, the speed of the camshaft and the crankshaft in the 2-stroke engine is same. It's 1:1 ratio, and for the 4-stroke engine, for the 2 revolution of the crankshaft there is 1 revolution of the camshaft, because in two-stroke diesel engine, whole cycle completes in one revolution of the crankshaft, and for the four-stroke diesel engine, the whole cycle completes in the two revolution of the crankshaft. Okay, let's move to the next question. Engine having a bore exceeding 250 mm but not exceeding 300 mm are to have at least, and the options are 3 compression rings per piston and the minimum of 2 oil scraper rings, 1 intake and 1 exhaust valve per cylinder provided no other means of scavenging is used, 1 explosion relief valve in way of each alternate crank throw with a minimum of 2 valves, 1 crankshaft except in cases where an opposed piston design is required. And the correct option for this question should be 1 explosion valve, a relief valve in way of each alternate crank throw with a minimum of 2 valves. Yes, this is the correct answer. Now let's see, what is explosion relief valve? What is its function? Explosion relief valve. Yes, a practical safeguard against explosion. It protects from explosion which occurs in a crankcase, and explosion relief valves or doors are fitted. These valves are served to relieve excessive crankcase pressure and stop flames being emitted from the crankcase. Yes, it is fitted in the crankcase and it protects from the crankcase explosion, and it relieve excessive crankcase pressure which and stops the flame from emitted from the crankcase. Thus it is a safety device for the crankcase. Okay, let's see the image. Yes, you can see a good image over here of yes, this is one of the good image. Yes, you can see it's a crankcase relief door image, and here is the spring clip spacers sealed and wire gauge flame trap, spider or dutlet, and synthetic rubber seal, valve aluminum. Let's see, there are, if there are other images also, you can reach some website. Yeah, the images we explosion relief valve, the images we discussed just now. Cover, it's the cover, spring retaining plate. It helps the spring to be in position, and this is the spring which works against the pressure. If the pressure rises above its limit, it opens the flap. Valve guide and valve o-ring works as a seal, and valve drainer, gauge assembly, and all these are parts. Now let's move to the next question. The opening of an exhaust valve on a modern large low speed main propulsion diesel engine may be actuated by. Yes, now the time has changed and modern technology has come, and this is still a bit older technology, and this is the correct answer for this question is hydraulic push rods. Nowadays hydraulic push rods are being used for the opening and closing of the exhaust valve. Let's see how it works. Hydraulically operated exhaust valve. Images. Yeah, it's a good image. Yes, you can see the cam. The cam is actuating this pump, hydraulic pump, and this pump pressurizes this oil goes over here and it pushes the exhaust valve for its opening. In the exhaust valve you can see the valve rotator. It helps to rotate the valve so that the deposits can be crushed and there is no deposition which can damage the valve seat. Okay, and it also helps in fair distribution of the temperature. Okay, now let's move to the next question. Shaker, circulation and spray are the three general methods used in the person who have watched my previous video will be easily answer this question. Yes, it's easy question. This is the piston, it should be the piston cooling. These all are the three methods of piston cooling: shaker, circulation and spray. You can see, let's see shaker type of piston cooling. Shaker cooling of piston images. Yes, this is the image of shaker cooling. When the piston moves up and down, the oil splashes over all the surfaces and removes the heat. And now let's see the spray type cooling in the spray type of piston cooling. Yes, through these nozzles the oil is sprayed over here on the surfaces. After the cooling, it is returned back. One more was circulation type, right? Circulation type, let's see circulation type of piston cooling. Yes, in this it's a water cooled type and also a circulatory type. In this system, the water or oil goes inside this space and it is completely filled, and it removes the heat by a continuous circulation of the cooling medium. Okay, now let's move to the next question. The speed of the camshaft in a two-stroke cycle diesel engine running at 950 rpm. Yeah, we already discussed that in the two-stroke engine the ratio of the speed of the crankshaft and the camshaft is 1:1. And in this question it is already given that the running at that the crankshaft rpm is 950. Hence it's a simple question. It's simple that camshaft will be also rotate at the same speed. It should be 950. Yeah, let's see. Yes, it is the right answer. Explosion relief valves on diesel engine crankcases should relieve the pressure at not more than 0.2 bar. It's a experimental data, or it's maybe calculated. I don't know much about it, but just remember the answer should be 0.2 bar. A two-stroke diesel engine exhaust temperature will be lower than a four-stroke diesel engine of the same displacement because scavenged air is cooling the exhaust gases. Exhaust cycle time is longer. A situation is given over here. A two-stroke diesel engine exhaust temperature is being said that it's lower than the four-stroke cycle diesel engine, and there are two causes are given. These are scavenged air is cooling the exhaust gases, and the second, exhaust cycle time is longer. In four-stroke cycle, exhaust time cycle is longer, but here in this question the two-stroke diesel engine is being said that exhaust cycle time is longer, so this won't be the answer. And there is a possibility this is the correct option, that scavenged air is cooling the exhaust gases. If the scavenged air cools the exhaust gases, then hence the temperature will get automatically reduced, right? So this is the correct answer. The sealing surface of a diesel engine piston rings are considered to be faces in contact with the cylinder wall in addition to ring groove. Bottom, it should be bottom, because from the pressure we will see it in a diagram. It will make you more clear. Piston ring arrangement in combustion in cylinder. Let's see a good image which will clearly shows our problems. Yes, let's see this image. No, this is not the correct image. Let's see the half section view. Yes, you can see in this image the combustion pressure will act on these springs, and it will force the spring to goes down, and a sealing arrangement will be made when the spring will touch the bottom of this groove. Okay, hence to make it sealed properly, you can see, yes, this is the image. You can see this is the top ring, and when the pressure acts through these passages, combustion pressure acts through these passages, it will move the piston ring down and it will touch the bottom of the groove for proper sealing of the combustion space. Hence the correct answer should be the bottom. Okay, that's all for today. See you soon.